This video will show you how to enter the data for your paper. And the paper, remember, is describing a fake study, and so you'll need to enter some scores into SPSS that will produce correlations that make sense. And by make sense, I mean correlations that are consistent with what your articles report about the relationships between the variables that you're interested in. So I'm in SPSS version 22 and I'm in the data editor window. It's time for me to name the three variables that I'm going to use in my fake study. So I'm going to click on variable view, and here I get to name my three variables. The first one is self-esteem, the second one is depression, and the third one is anxiety. Now that I've created those, I can leave all of these other settings to their defaults. I can go back to the data view now to enter the scores, and you'll see that what happens is my three variables are now three columns. So because your study is fake, you get to enter scores that will be convenient for you. You can pretend, for example, that your first variable is measured on a 1 to 5 scale. So I'm putting in scores here that conveniently rise in order, and I'm working with only 10 rows to begin with because I want to get scores that will work for me with 10 rows, keep things simple, and then later on I can double the size of the sample by copying and pasting the first 10 rows, and then I'll have 20 fake participants. So right now I have self-esteem scores that conveniently go up from 1 to 5, and I need to think about what my depression scores should look like in the next column. I've downloaded an article that tells me that self-esteem and depression are negatively correlated with each other. So I need some depression scores. Let's just imagine that my depression variable was measured on a 1 to 3 scale. I need depression scores that range from 1 to 3, but that will produce a negative correlation with self-esteem. So here are some depression scores. In general, you see that lower depression scores are being matched with higher self-esteem, and generally, high depression scores are being matched with lower self-esteem. I can double check whether these scores are going to work the way that I want them to and produce the correlation that I need by going to the Analyze menu, clicking on Correlate and Bivariate. I want to move over self-esteem and depression. I haven't entered any anxiety scores yet. So I'm going to move self-esteem and depression over like this so that I can check the correlation between these two variables. And I also want to click this options box and request the means and standard deviations for the two variables that I'm correlating right now. When I click OK, all of these other defaults are fine. When I click OK, the output window opens. You see that the first table contains the means and the standard deviations for the two variables, and I get a reminder that I'm working with only 10 fake participants right now. The second table is where the correlations will appear, but I only have one correlation right now because I've only entered self-esteem and depression as the variables of interest. When I look at this row that's labeled Pearson correlation, and I come out here and I match up depression and self-esteem, SPSS is telling me there's a negative 0.51, if I round to 2 decimal places, negative 0.51 correlation between self-esteem and depression. Let's just imagine that I'm satisfied with that correlation. It will work for me. So I'm going to leave this alone. I don't need to save this output window right now because I'm not done. I need to go back and put in some anxiety scores. So I'm going to close this output window, return to the data editor, and now I need to think about what scores in the anxiety column are going to give me the correlations that make sense. Let's imagine that my articles are telling me that anxiety correlates negatively with self-esteem and anxiety correlates positively with depression. So I need to put some scores into this anxiety column that are likely to give me those kind of correlations. Notice how these anxiety scores match up with self-esteem, and then also how these anxiety scores match up with depression. You'll see that this first person is highly anxious, they're also highly depressed, and they have low self-esteem. Down here at the bottom, they are not at all anxious, they have low anxiety with a score of 1, and they have low depression, also a score of 1, and then they have high self-esteem. So I'll now check whether the patterns that I think will emerge actually do emerge. I go to the Analyze menu, then Correlate, Bivariate. I now want to look at all 3 correlations at the same time, correlations among all 3 variables, so I'll get a total of 3 correlations. I still have means and standard deviations checked. All of these defaults are fine, so I click OK. The output window opens. You see now that I have descriptive statistics for all 3 variables. Down here in the correlations table now, the depression and self-esteem correlation did not change because I didn't change any of those scores. But I entered anxiety scores, and now I'm seeing, as predicted, a negative correlation between anxiety and self-esteem. And I'm seeing a positive correlation between anxiety and depression. All of these correlations are fine according to the instructions that are in your handout for the paper. But for the sake of showing you the kinds of changes you may need to make, the kinds of struggles you may have along the way as you're entering these data, let's just imagine that they are too large. If that's the case, I need to think about this. These are both correlations with anxiety. So if those correlations were too large for me, I need to go to the anxiety column and change something there in order to make those correlations smaller. So I'll close this output window because I'm not satisfied with the results that I got. I'll go to the anxiety column. That's where I'm focused right now because it was the anxiety correlations that were unsatisfactory to me. And I don't want to make a lot of changes. Just remember, in a tiny little data set like this, changing just one score is changing 10% of the scores for that variable. So I'm going to take this one score. Right now that person has low anxiety. I'm going to make that person highly anxious. And let me see now how changing that one anxiety score changes my correlations. I've got all 3 correlations. I've still got the means and standard deviations selected. All the defaults are fine. Now I'm looking in the output window, and if I scroll down to the correlations table, I see, of course, the self-esteem and depression correlation didn't change at all, but my anxiety correlations, both of them, both of my anxiety correlations are now smaller than they used to be. The negative correlation is still negative, and the positive correlation is still positive, but it's moderate rather than strong. So if I'm happy with the results that I see, I still don't want to save this output, but I want to go back to my data set and now copy and paste the data that I have. I'm happy with the correlations that I see, but I need 20 participants now. If you want to work with 20 participants from the start, you can do that too, but I find it easier if I'm having to enter scores to only be thinking about 10 rows of data at a time. So if I'm satisfied with everything and I'm ready, I can copy and paste the first 10 rows of data down below. I now have 20 rows worth of data representing 20 fake participants. And if you think about it, with the copying and pasting that I just did, the correlations are not going to change because I have kept all the matches between the scores the same. So I can confirm now that with 20 rows of data, I've got all of the results that I need, and all of the correlations look appropriate. My sample size is appropriate. My correlations are still what they were before because all the matching between the scores is still the same. It's just in 20 rows of data now, and this all looks good to me. I can save this output. When you save in this window, you're only saving the output. And I can also save my data, which is a good idea just in case I find, maybe I'm writing my results section later and I realize I made some mistake. So save your data just in case you need to open it again later on and adjust some scores to get the results that you need. I hope this video has been helpful. Let us know if you've got any questions.